Here is once again my GW Instek power supply. It recently started doing something weird and very intermittent, where both CC indicators would turn on and both outputs would fall to 0. Normally this happens when you're changing modes with the tracking switches, like if you're going from independent to series or parallel. But it's doing this on its own. I tried poking it, applying pressure, because I was suspecting something mechanical, but I couldn't isolate it anyway, so I had to dig deeper. Luckily, we're not entirely in the dark to work on this, but I'm only aware of these schematics, which are for the Tektronix PS280 and 283 power supplies. They're mostly the same. This one was published 91, and it's close enough, but there are some differences and some actual errors too. Page 3, things get fishy here, and I'll definitely come back to this later. This is essentially unusable. All the top part is different. The switching part and the feedback, those are actually good. Not quite good, actually. These pinouts on these two ribbon connectors, you can't trust these. And they end up on one of the later pages, pages 5 and 6. Before I get there, page 4 here, this one's fun. Look at this relay here. Normally open, normally closed, connecting the positive side of the master output to one of... No, that's obviously wrong. This is a no connect on pin 4. I validated that on mine and it just makes sense. Around here, just misleading. You're trying to understand things and then you see something like this here, plus 24 volts. No, that's wrong. That's minus 24. Thank you. Pages 5 and 6 are very similar. Those are the master and slave output regulators. There's some minor differences here regarding voltage and current feedback. I haven't messed with these much. It's just hard to read because it doesn't tell you that the first 2 pins, this is a 10-pin connector, but the first 2 pins are split and they go to a different place. And on top of that, the pin, like I mentioned earlier, the pin numbers aren't even right, so very frustrating. So about that page number 3 that covers the voltage, current, and tracking control, I quickly realized that the schematics I had didn't really match, and it was going to be a problem. So I took pictures, then I went through the whole process of, well, first of all, here I'm stitching pictures together because the PCB was a bit too wide and it was hard to get a good enough picture for the front side, then the back side. This is to stitch the 2 pictures together and get the rotation and the distortion corrected. This works pretty nicely. For single photos or smaller boards, this step is usually optional. I can sometimes either throw them directly in GIMP, or I skip to this second step where I then take the front and the back layer and I set control points on vias and features, and then I let it adjust parameters. That just makes lining up the layers much easier later in GIMP. Again, this can be done manually all in GIMP, especially for a through-hole board like this where it doesn't matter if you're off by even half a millimeter, it's going to be pretty clear what's going on. But for surface mount boards, anything more intricate, then it pays to put a bit more effort. And here's the result. I'm going to cover very broadly how this thing works, even though I don't understand parts of it fully. I think it's just going to help for the rest of the video. Let's see. So I'm going to start with the easy stuff. This blue box, this is the output terminal PCB. There's a bunch of capacitors. There's 3 relays. This I think is on page 4 in the schematics, and it's close enough, minus those errors. And the connector pinout is also different. I just put that there for reference while I was tracing here. It was helpful to sanity check. So this is driving 2 relay coils with these. I don't know why they felt it necessary to put these, but whatever. And there's an extra pin here that has to do with, I I think current feedback when operating with the two outputs in parallel. I'm not sure exactly how that interacts. Doesn't really matter either. This blue line is just to indicate a bit of insulation. This connector goes to the master side, and here's its voltage and current settings, the front panel LEDs, and this optocoupler, when it's on, it forces the output side to 0, and as a side effect, it'll also turn on the CC, the red LED, and that's what I was seeing. So I knew for sure this was turning on and off. So that's for the master side. On the slave side, they did not use an opto because most of the control section is powered from the slave side. So they use, as far as I understand, this transistor to do the same thing, which is to force the output to 0, and the LEDs are down here. The switching arrangement is complicated. I don't see a better way of arranging this, and it doesn't really matter either. Up here is this 555. This matches the one in the original schematics, mostly. And this one generates a pulse for as long as these switches are between positions, and it extends the pulse. And this has the effect of disabling the outputs while these relays are switching. And the last relevant part is up here, controlling these two transistors that trigger that pulse. Some of these contacts on the switches, and even this weird configuration with the ground on both sides, that's just to generate a pulse when this contact is in transit between positions. Working on this board was a bit of a pain until I accepted to remove the front panel entirely. It's just a pain because, well, for some reason, they have wires like this soldered at both ends. Like, why did they not put that on the connector? And this connector is, this one's removable, nice, but the other end is a soldered board-in connector. Anyway, after verifying the basics like supply rails and all that, I started at this end near the optocoupler. I verified yes, it was indeed toggling, and then back up to this U501 555 timer, and this was indeed toggling. Then I moved to the trigger pin, and I noticed that even just touching it with a probe would trigger it. That shouldn't really happen because there's a 10K pull-up, and the multimeter is a very high impedance, so I had reason to suspect the 555 maybe was bad. Okay, I threw a new one in there in a socket. Let's see if I can still do that. If it clicks, then I failed. It's not clicking. And it's fine now, I think. It's not supposed to click like that. If it goes into constant current, like, well, yeah, there you go. Okay, so that wasn't the problem. I'm probing R520 on the left side, and with this scale, if I press one of the panel buttons, the rectangular pulse that I see has about 24 volts amplitude. But when I hear the intermittent clicking, it's only this little, very short burst. Let me see if I can catch that. Alright, so if I push the button, that's what I see. Nice pulse. And if I hold the button halfway, let me see, like this, I can actually have it stay at the high level just because I'm between contacts on the switch. So there's something weird going on. For the next test, I was going to be disconnecting a lot of things here which could mess up the logic that controls the outputs versus the relay sequencing. So what I did to avoid the risk of having the wrong set of relays turned on was to disconnect this 5-pin connector that goes to the terminal board. And I also made sure never to engage the parallel mode while the switch was on the tracking position, because when you put them in parallel, then you connect a bunch of stuff on the output board. here I'm just going to summarize a bunch of steps that I took because they weren't very interesting. First, I disconnected R510 here, and with that I wanted to make sure that 501 wasn't turning on 503 and causing those triggers. And doing this, there were no more spurious triggers, so I reconnected this. Then I removed this entirely just to be sure. Well, that was a bit redundant, but I tested it anyway. Everything was fine. Then I put it back. Then I moved to R501. I disconnected this. I'm not sure why I tried that. Anyway, it wasn't a very useful test, and I disconnected R502. And doing this, I could see that the glitches were back, which meant something was going on with some of these components. Either, well, yeah, one of these. I suspected the diode because semiconductors. Well, I got a new diode installed in there, and it's still doing it. Stranger and stranger. By the way, it's clicking not because I got the output relays plugged in, but I set the voltage. So this is counterclockwise the lowest voltage. I increase it until it changes taps on the transformer, so that when it falls into CC mode, then it drops on. Anyway, audible feedback is all. I don't understand. So even with the new diodes, it's still doing the same problem. I just had a thought. I'm probing. This is the, well, it's not the 24 volt rail, but I got my ground probe on -24, and this is probing the ground, and this looks like a ramp, which would happen if the 24 volt output got disconnected for some reason and it was discharging. I'm going to disconnect a bunch of stuff and see if I can probe this 24 volt supply where it's generated on the main board. So I had these two connectors at both ends, 8 and 9 pin connectors off, and still probing that -24 volt rail here, and I couldn't see anything happen for about a minute. So I'm wondering if that little dip I was seeing is a cause or a consequence of something else. So what I'm trying now is, I got that board reconnected, and I'm trying two things. First, the high-tech tool here. I'm shorting pins 4 and 5 of the optocoupler, and that simulates, on the master side, it simulates that condition where the, yeah, okay, so that works. Obviously it works, but more importantly, it didn't generate anything on the 24 volt rail. On the one controlling the slave side is a bit more complicated. I need to force this to turn on. I can either, well, heck, I can probably short pins 1 and 2. What's the worst that can happen? Okay, so that's shorting pins 1 and 2, and still no response on the 24 volt rail. I just changed the probing setup. Blue trace is the high voltage rail, the 20 plus 24. It's all upside down. Bear with me. The green trace is the output of the 555. I should have done this earlier, but that was just to clarify that the output of this 555 is the consequence of this glitch and not the cause, so that's good. I'm still not closer to the real cause. all right. Oh, these fuse look pretty good. They look good. So here's one. I'm measuring the voltage drop. Okay. 0.18. How about the other one? 5.8. Yeah. There we go. Now, a fair question would be, if it's such an obvious failure, why did I not check it first? Well, I kind of did. The first thing I did was to check the plus and minus 24 volt rails right on these two filter caps, check the 15 volt rails, did all that. But because this is a full bridge rectifier, if one of the phases is disconnected because of the fuse break, it's off the sheet here, but I'm still getting the two rails. And I assume if that fuse was making intermittent contact, that would sort of generate those glitches I was seeing on the rail, and that would be enough to... that would completely explain the symptoms I was seeing. So, I guess it's the second time I have a fuse like this. It looks okay, and it kind of behaves almost all right, but it doesn't. I think I got to move that test higher up on my checklist, like measuring the voltage drop across the fuse like I did, because that doesn't lie.